and today I had a long day at work.
Understand. Yeah, we're all electricians, so that's what happens.
Right.
Yeah. On those questions, just keep going over those questions. Go just get them in your head. So
Okay.
there's no trick, rhyme, or reason. They're notorious for asking some off the wall questions, and that's what you got right there. So
Okay.
just I trying to help you out with getting that book and everything, but a lot of those questions, especially in the beginning and towards the end, a lot of those come from that lineman's
Okay.
book. So besides that, we need to
Are
go.
these just possible questions, or do you know for a fact these are in the test?
These are possible, very good possibility. They could show up on the test. Let me just put it that way. There's a large bank of questions that they pull from, but from what I'm hearing, from what I'm talking to guys, that's where I'm coming up with these questions. They're you're gonna see them. You're gonna see them.
Okay.
Um, Another thing that you're gonna see is you're gonna see a lot of parallel resistors,
Mm-hmm.
the math on that. So that's what I want to take care of tonight and show you how to get that done. Also, we'll do some parallel resistors, and then go over some graphs, some sine waves and stuff that you'll probably see also.
Okay.
First off, are you familiar math wise with parallel circuitry, how to figure that at all?
I've um I've gone through it, but I haven't really learned it like as far as
Okay.
memorizing it.
Okay. um I, there's one method. It's let me get this going here. It's product over sum. So product is what you get when you, like, if you multiply 1 times 1 equals 1, that's the product, over 1
Okay.
plus 1 equals 1. So maybe 1 wasn't the best number I could have checked, but product over sum is easy, because if you remember product over sum, product means to multiply, sum means to add, and this right here is division. So it's product over sum. So if you remember product over sum, that means multiplication, division, and addition right there. So let me show you what I'm saying. Let me show you what I'm talking about on that.
Okay.
What you're gonna see is I've got some examples here. Let's start off with a pretty easy one. You'll see something like that. I'm not an artist, so bear with
Yeah.
me. And then they'll come in here and they'll throw another resistor right here,
Mm-hmm.
and they'll give you 40 ohms. And then they'll give you 20 ohms right here for this resistor. And then they'll ask you what the total resistance of this circuit is.
Right.
So that's where we use the product over the sum. So what you do is you'll take 40 times 20 over 40 plus 20,
Okay.
and that'll equal 800. over 60. And then you divide that out. You divide 60 into 800. And you'll come up with 13.33
ohms.
Yes, total resistance. That's the total resistance of that circuit.
Okay. 13.33. All right.
I'm throwing these numbers at you, so study these numbers also. Not saying you're not going to see those numbers, but you may see those numbers.
Okay.
So we'll just that's how you do with two resistors right here, 1 and 2. Now when they're going to throw some,
that's if you have a parallel circuit.
Exactly.
That's if you have a parallel. Okay.
That's and they're, from what I'm hearing, that's what they're going to throw at you.
Okay.
Parallel.
I think I might have seen it because I remember I tested back in May.
Still there?
I think I might have seen that question.
I'm not surprised.
How does it reference to alignments? I mean, I have 20 questions on low voltage, including alarms. I have 5 questions on electrical signs and outlighting, and then I have cathodic protection and lighting protection. 5 questions on that, and then 10 of telephone and computer systems, and then 10 of sound and communication.
So where most of those questions are most of the parallel and series circuit is they'll throw cathodic protection in there. You could work that out because they say cathodic protection or grounding, but and then they throw a resistance in there, and that's where they get away with the resistance portion of it. So they're putting that in. So where do you think you saw that, like that question we would just went over? More specialties or something else?
Yeah, probably in that portion of the test.
Yep. Okay. Like I said, product over sum. Now
it was a little different when I took this test because this is the first time I take it, and I wasn't even prepared for it.
Right.
So yeah, I was like seeing all these random questions, and I'm like, God damn.
Yep. But, and that's and you got to remember, PSI is in the business of testing, so that's what they do well. So
yeah,
they test you well.
Make sure you go back, huh? At least.
Yeah, that's $75 or whatever, $78 or whatever it is. Yeah, that's how they make their money.
Yeah.
So let's work on this one. What it is, it's going to be a circuit with 3 parallel resistors in it.
Okay.
And there's a little bit more to that than that we're just adding off of product over sum. So you're gonna have a 30, a 20, and then a 10 ohms. All of them are ohms. And then they're again, they're gonna ask you what the total resistance is. So what you need to do is you'll just break this down. You'll go 30 times 20 over 30 plus 20. And then you're going to get 600 over 50. And divide 600 by 50. And you're going to get 12. Now, you take this 12 right here, and you go 12 times 10, this 10 right here. And
Yes.
then you go over 12 plus 10 and just work it out. Just keep working it out, which is 120 over 22. It's 5.45.
Okay.
So
that would be the answer, 5.45?
That is correct. 5.45 ohms. They may round it up to 5.5 in the test, but there's nothing going to be close to that number right there. You know, they'll put a 36.7 and a 0.01 or something. You know, it's going to be, it's not even going to be close, because they get a little tricky, you know, with this decimal. You know, yeah, you could round it up to 5.5. So just be aware of that you are there. You could round it up, but if you're close, that's it. Because we can get into some where the hundredths decimal, you round it up and it messes with the number a little bit, but don't get all freaked out. You got it. You know, if you're close, you nailed it.
If you do the same, I mean, if I calculate it the same way, right, it should be good to round up a little bit.
Yeah. And it's going to be obvious, you know, A, B, C, or D is going to be real close to what you come up with. And the other three are not even going to be in the ballpark. So it's product over sum. Just remember that. So I want to give you a shot to make sure that you know that you can do it. So, oops, let me clear the board here.
Okay.
And this will be, let me see if you got it. And if you don't, that's cool. We'll go over it again. Let's just do this. 20, 20, 20.
We got 6.6.
You nailed it, man. Cool. That's it. That's all you gotta do. What's that?
All right. And there's only the parallel with two resistors and 3, or is there more?
Yeah. From what I'm hearing, 3 resistors are the max. You got to remember, you only got like 2 minutes, or you know, your time frame is not allowing them to give you a real complex situation, because it's not fair to you if I don't know if you've done the division and worked out if it's 2 minutes a question or 5 minutes. You know, they can't get too complex because of that.
Right. That's why they break down the calculations like a demand load.
Right.
They break it down into smaller portion of questions.
Exactly.
Yeah, I got.
Yeah. So you're not gonna when you do your residential or your commercial, you're not gonna have to figure out a big old warehouse and then figure out the conductors, the service conductors coming in, and then the bonding jumper that goes with that, and the electrical grounding conductor that goes with that. You don't have enough time to do that.
Yeah.
So that's why they just pick a little bit of everything out of there and then ask you about it. So I want to show you
Right.
if you see one like this, if and when you see one like this, there again, I'm not an artist. And it's going to be 100 ohms. It's going to be a 100, 100, 300, and 100. Did you see that one yet on the test?
I don't think so.
Okay. What I need you to do is just remember this one. So make sure you write it down. You take 300 plus 100 is 400. And that's your total resistance of the circuit.
Okay.
That's pretty much a softball, a give me. That all you have to do is remember that 300 plus 100. Don't get caught up with all that other 100s down here. And that's probably the I've heard multiple guys see that parallel series circuit, that one right there. So just remember 300 plus 100 to get you going on that. Just work it across that top, and that's going to be your answer. You're going to see a 400 there and nail it and move on.
Yes,
that one's going to be an easy one to go with. So they're also going to be asking you if you can identify that circuit. Is it a series parallel, or are they throw another one at you? So do you know what that one is?
No, I don't.
Okay, cool. That's cool. Then let's go back a little bit, and so we're looking right here. Whenever you see it like this, you work oil field or commercial, or what do you work?
Yes, oil field.
Gotcha. That's where I started. I started in the oil field in Hobbs.
Okay, that's where I'm at right now. They're sending me out that way.
Oh, really?
Yes, sir.
I haven't been out to Hobbs in a long time, but I spent about 5 years out running the Permian Basin right there. So
I'm trying to get out of there.
I hear you.
Over here.
What's funny is when I was in Hobbs, I spent 1.5 years in Odessa, and that's where I left, is when I was in Odessa.
Oh, cool.
So anyways, this right here, this is a series circuit design.
Okay.
So series is, you can't run, you have to go through 1, 2, and 3. The series circuit is only one way you can get through that circuit is in that series circuit. Now, if you had this,
It's a parallel.
there you go.
Okay.
So that's the difference right there. Is your series circuit is almost a circle, or the voltage only has one path to travel.
Okay.
With
that makes sense.
With that parallel, it could jump down. Oops, dang it. It could jump down, it could go down any of those right there.
Right.
So that's a parallel. This is a parallel versus the series right there. So familiarize yourself with those.
Okay.
Familiarize yourself. Like I said, I haven't had anybody coming back needing series math. It's all been parallel. They've been throwing parallel at you guys a lot.
Okay.
So work with those numbers and practice that product over sum.
Yes, sir.
If you get caught up and maybe you see a series, just remember product P parallel P, product over sum parallel. So easy. Those are just easy peasy.
All
so
right.
Another thing I want to go over is this right here, identifying different, got a wave like that. Do you know what kind of wave that is?
No.
That would be like on a scope.
Haven't seen that.
Okay.
On a scope?
Yeah, it would be a wave off of a scope. So what they're looking for is sine wave.
What type of question would this be?
That right there. That's it right there. What type of wave is that?
What do you mean?
That's so this is an analog wave right here. So what happens is this is the plus and this is the minus, and this is your 60 hertz per second is what it is. Your waves going up to 60 and then it comes back down. I'm sorry, not to 60, to 120. This is not on the test, dude. I'm just trying to give you some knowledge on what it is. So it's 120 here, and then 120 back down. So that happens every 60 beats per second. So that's where your hertz your 60 hertz come from. So on the test, they're going to ask you something like they're going to ask you what that wave is, what type of wave that is, because there's also this type of wave.
So that first one, what is it called again?
This one right here is a sine wave.
Sine, okay.
Yep. And I'm just throwing some knowledge at you on this top one up here. It's a digital wave. So this down here is analog, and then this is digital. So maybe are you dealing with VFDs out there in the field, maybe pump stations or satellites or something?
No.
No.
Sometimes VFDs, but right now they just have us doing maintenance.
Okay.
I'm working for XTO right now.
Okay. VFD produces this type of wave right here, the top wave. Like I said, dude, this is not on your test, so I'm just kind of giving you some understanding what's going on. Your VFD produces a DC wave, And then the regular AC current is this. So it's a sine wave.
Okay.
So also, man, I'm recording this. If I catch this recording, you're gonna get a link to this recording. So you can go over this stuff, and because tomorrow life happens and you're gonna be like, man, what the heck was that? So
yeah.
Hopefully I'll catch this all, and then you can have it all with your notes that you're taking right now.
Yes, sir.
So also, you're gonna see another sine wave like this, and they're gonna tell you something about 10 seconds per, and per, golly, I can't remember what it is per, and what they're asking for is per block, and they're not going to call it block or grid line. So what I'm calling a block is like from here to here to here, this right here.
Okay.
So they're gonna give you something like let's call this A and call this B, and we're assuming the crest of these waves are at A and at B, and they're going to ask you how much time, what's the time frame, or how much time has been in between point A and point B. So literally all you have to do is you have to come in here and go, there's 10 seconds, there's 10 seconds, 10, 10, 10, and we'll call this one the last one since I was a shitty drawer. So 1, 2, 3, 4, 5, 6. So you got 6 blocks. Multiply that times 10. So that'd be 60 seconds in between A and B.
Gotcha.
Not bad, pretty easy. Just
yeah,
it's easy here, but when you're in the middle of a test and you see something like that and you're like, that has nothing to do with turning anything on or making anything run. So that's another easy easy question there. Just count your blocks, from A to B, and you're good to go. And look and see, I'm thinking it's 10 that they're trying to determine the block. So just look at your time that they're giving you for that, and then add it up. So also be on the lookout. Let me see if I can utilize this awesome drawing. Then they're going to ask you, oops, let's see, they're going to say 1 volt here and 1 volt here on this line, and then we'll call it this line, and we'll assume that I took this all the way down to here. So so they're going to ask you what's the difference between, what's the voltage difference between A and B.
Okay.
There's no math involved. If just check this out. So right here is 0 on this horizontal line. This side right here of the line is negative. This side right here of the line is positive. So if you take 1 volt here, which is a positive, and add a negative volt to it, 0 is your answer.
Okay.
So you remember how we learned how to count, and we'd always start at 0, 1, 2, 3 as we were learning how to count, but then eventually we learned how to count -1, -2, -3. That's all this is.
Yes.
So don't get thrown off on that. That's another easy one that if you don't know, then it's extremely hard. So they're going to be asking you what the voltage difference is between this and this.
Okay.
So be on the lookout for that. Easy one on that specialties.
So if it goes up 5 and then it drops 4.
Yeah, there you go. So
like that.
It'd be a 1 difference. 5 minus 4.
Okay, gotcha.
5 minus 4. So so if this one, like you said, was 5 and this one was 4, you just take 5 minus 4 is 1, is a positive 1.
Okay.
Easy if you know it. It's a curveball if you don't, if you're not aware of it or not prepared for it.
So, I mean, I know you're in the area where they take that test. I mean, how is it for everybody else? Do people struggle with it?
I'm telling you what, the one thing they struggle with, and it sounds like you're struggling with it too, is studying. You have to study.
Right.
A gentleman called me today, and he missed his journeyman's by 2 or 3 questions, and he hadn't been studying.
Right.
But you got to study.
Right.
You have to study.
Yeah.
You have to.
Yes,
and by studying, it's 2 or 3 hours a night.
Like I was telling you when we first spoke, I mean, I understand the concept pretty good whenever I study the references. The issue that I have is that I don't retain it. Like I'll forget, and then a week goes by, and then when I get back to it, I might have already forgot. Right.
Exactly.
But I'm getting better at it, but my work schedule doesn't help because sometimes I make it home at 7 or 8. By the time I shower, get out, and try to study, it's already late.
I understand, man. I've worked your schedule. You work from sun up to sundown. I know. I know. So that's probably the hardest part of the test right there, is getting your study time in. It really is. So that's it. You've already taken the master's in Texas, and you probably had to study quite a bit on that too. So it's the same thing. It's some of these guys think they can just go in there and it's a jump shot, and no, it's not, man. It's a hard test if you're not prepared. That's the hardest thing I can tell you that I'm finding, guys. That's kind of the first thing out of my mouth is, hey, have you been studying? How many hours a day have you been studying? So that's it. So cool. The specialties, that math portion of it is pretty much the weird stuff that you're gonna see. How is your Ohm's law?
Good.
Pretty good. Pretty good.
Yeah.
Okay, so if I would erase all this crap. Oops. Let me get back to that. There we go. So if I said, what's the primary voltage? Sorry, the primary voltage is, and you're out in the oil field, so you deal with 480 on a 35 kW transformer. What is the primary? What is the amperage on the primary side?
You got that one, bro.
Okay, that's
you know
cool.
why? Because I really can't get the transformers. I don't know why I can't get the transformers.
Cool.
That's a big one.
All right, good. I'm here for, if you have anything else, just let me know.
I haven't really got it down because I know on the test it only throws like max 2 or 3 questions on transformers, but I don't know. Like I don't know if you know a better way to learn it, but I don't know why I struggle with it. Maybe because I haven't put in the time.
Let me throw this at you. This right here. You can solve it with a piece of pie, and remember that, a piece of pie.
Mm-hmm.
So, you're looking for amperage. You've got pi is your current, which is 35,000 watts, because we did a kW right here. K means 1,000.
So, okay, I think you got to multiply, 480 times 35.
Nope. Just
Oh,
like,
because it's a 3-phase.
nah, just bear with me here. So,
all right.
have you seen that? Have you seen this before? Have you seen that? Has anybody explained this to you before?
I've seen it.
Okay.
And I'm sure I've studied it, but I don't remember.
Okay. It's no big deal, man. So power is your wattage.
Okay.
E equals voltage. And where I'm getting this from is if you get on the Uglies book, or if you see an ohms wheel,
Mm-hmm.
PIER is in the middle of that ohms wheel.
Yeah.
And that's where I'm getting P equals watts, E equals, God, I cannot spell today, volts, and I equals current or amps. Let me spell that right. So you take the P is, if you're looking for P right there,
Mm-hmm.
P equals I times E. If you're looking for I equals P divided by E. Or if you're looking for E, it's P over I.
Right. So we divide on this one.
Exactly. But be aware that we've got 3,500 watts, because we came up here and it was kW, so we moved the decimal place over 3 places to take it from 1,000 to take it from a kW to watts.
Mm-hmm.
And then we divide it by 480, but since it's a three-phase system, we know it's three-phase because it's 480.
Yeah.
You have to multiply. Oops, sorry about that. You have to multiply that 480 times the square root of 3, which is 1.73.
Okay.
And remember, remember every time it's three-phase to take the square root of 3. So on that calculator they're giving you, if you don't know 1.73, you just put in square root and then 3, the square root sign, and then 3, and then it'll give you 1.73. So now we take 35,000, and let me get my calculator out here. And that equals 830.4, because we took this and multiplied it.
Okay.
And now by code we can drop the 4, and then we just divide. So you take this 35,000 and divide it by 830, and you come up with 42.1 amps.
35,000 divided by 480 times 1.732.
Yep.
And then we divide 35,000 by 30.
Yep.
Okay.
And that right there is your amperage on your primary side.
Okay.
Now, they could give you the secondary side. 208. Remember, 208's three-phase. So all you would do is take this number right here and replace it with 208.
That's it?
Yeah. And work it out.
So whenever they ask you a transformer question, you're looking at Ohm's law?
Oh yeah, definitely.
All the time?
Definitely. There's, if
All
you
the time?
remember, if you remember pi, and they're asking for and usually it's the amperage, it's the primary or the secondary amperage. So they're going to give you a big old number, the wattage, 3,500, 125,000, or whatever it is. And then they're going to give you the voltage, which is probably going to be three-phase, because they want to know if you can if you knew the 1.73 trick, where you multiply the voltage times 1.73, and then you just work it out. So if you remember pi right here, if you remember that right there, you can work it out, because this equals all of this down here. You know, that's your formula right there.
Gotcha.
So, just remember, transformers can be solved with a piece of pie. That's it.
Yeah.
And that's how you work it.
That makes sense.
That's how you work it right there. And then, you know, on the secondary, on the secondary side, it could be 208. And if it's single phase, then you're just good. You're good with it. You just use that number and work it out. But it probably won't be single phase because they want to know if you know this right here, if you know to get the square root of 3.
Okay.
So
if they were to ask for volts, I would divide. I mean, I would divide watts times amps.
right.
Okay.
They're probably not going to.
You don't think so?
I would work on amps.
Okay.
Primary amps. Now, for in the code book, what do we get? 41. What do we get on that primary side? Do you have that in your notes or no? That we did. You know what? Let's work on this right here. Let me show you.
Which one?
Don't worry about it. Let me show you this one right here. What we're going to do is we're going to take 208 right here. Sorry, you can't see what I'm pointing at. 208 right there and multiply it times 1.73 and it's 360 or 359.8 or something. Well, we can round it up to 360 and then take that 35,000 divided by 360 equals 97.2, and that's your secondary side amperage. Now, if they want to know, your secondary, if your overcurrent protection on your secondary side, you need to take this and multiply this times 1.25 to get your breaker size.
1.25?
Yeah, it's 125%.
Where do you get that?
I don't have hold on, let me get my code book. All right, here we go.
And that would be your overcurrent protection for the transformer?
Secondary side.
So that would be feeding load center, for example?
Exactly. On a so we already know that the secondary side is 208. So in this scenario,
it would be like a motor or what?
Yeah, no, it'll be well, like you've got 480 coming in to the primary side of the transformer. And then on the secondary side, due to this number right here, it's going to be 208, which is that would be feeding your lights. If you had a dog house or something that only took 110, I'm trying to think, or a motor at 208 on the low side of the motor. You know how you've got a high side of the motor and the low side of the motor when you hook those up, like a transfer pump or something, and you can hook them up 208 or 480. So this right here is telling you that. And then you look under transformers.
Have you seen that question in the test though?
I've heard about it.
Yeah.
I've heard about it. Golly. Should know where transformers are. There's a table for transformers. Bear with me. Since I'm just 450, Article 450. Right behind motors.
I think the only
And
ones I see is 450.3, no?
exactly. There you go.
Thousand volt or less.
Maximum 1,000 volt or less. And if you look on the bottom where it says primary and secondary protection, and then all the way to the right where it says 125% seen. Oh, are you in the 17? Yeah, you're testing in the 17, huh? Or it's still the
Yes,
same.
sir.
And it says C note number 1.
Yes.
And see how it says 125%? Not in the note,
On
not
note
in the
one, it
note, but
just says
in the table itself.
yes.
Okay, currents of 9 amperes or more, and then you go down and it says 125%.
Yes.
That 125% is this right here.
For your breaker. Gotcha.
Now, hold on. We got one more step. So we got to take we take 97.2 times 1.25 is 121 121.5.
Right.
Now you need to go to 430.6. Let me see. You need to know where this table is right here. I don't remember where it is in the 17.
Which one are you looking for?
240.6. 240.6A.
Fuses?
Exactly.
Yes.
Okay. So we take this. Bear with me while I clean this up. Let's see. Let me get some room.
I have a question for you.
Go ahead.
My brother called me today and he had a question about a transformer he was working on.
Uh-huh.
Well, he said he was on site on the shop and he said that the voltage coming in was 240 and he said it was stepping up to 480. So he was asking me if I could help size the transformer because that one had burnt out for the motor it was feeding.
Okay.
I guess it was undersized. And he was asking me, do you know if this is a step-up transformer or is it a regular? And I was like, well, it looks like a regular transformer. Here, let me pull up real quick. It's a it's a 30 kVA, and then it says a high is a 480 and the low is a 240, 240, 120. So I called I guess the distributor and they said it's a general purpose, so it's a standard transformer.
Correct.
And we're saying it was a step down. It's a step down transformer. So I was like, are you sure that it's coming in with 240 and stepping up to 480? And he's like, yes, I was there. I checked the voltage.
Okay.
So how would how does they do that?
It doesn't matter. It works the same way.
You just wire it backwards?
Yeah. You feed your secondary side, your low side. You bring the power into your low side and it goes out the high side. Now you're not going to get as much amperage. It's going to take a lot of amperage on the low side to pump out what you want on the high side due to Ohm's law. So yeah, it could definitely be doing that. If he was feeding the secondary side, it could definitely be it could definitely be putting out some voltage on the primary side. It's just your amperage is going to be extremely low.
So if it okay, let me see. If this is
And it's a general purpose, it's a general transformer.
yeah,
It's just being fed backwards.
yes, sir. And I think it's feeding a 100 amp motor or
Oh,
load.
100
So
amp on the 480 volt side.
yeah.
Woo, what's he bringing in on the low side on the 240 or whatever?
What do you mean bringing in
Like overcurrent protection, or those conductors have got to be huge.
400 amps?
400 amps. You're breaking up.
Yeah.
Yeah, 400 amps. Yeah, that makes perfect sense.
What would you recommend to size the new transformer?
Um,
Would it be a 75 kVA?
is he not? Is he doesn't have three-phase 480 out there? I'd try to get that thing off of 240 if we could.
They don't, because it's a shop, and I think, and that's what I asked them. I'm like, you don't think they would like to change that transformer and feed a three phase? But I don't think so.
Sure. Okay, let me do some math on that one, and I'll shoot you a text on what it
Cool.
is. So,
Okay.
going back to this motor, or this transformer,
Yes.
the 208 side. So we did all the math down here, and we came up with 121.5, but they don't make a breaker that size.
Right.
So you're going to have to run it up to 125 amps.
Okay.
But you need to go back to 240.6a in that table to get the standard size, because they may ask you for the standard size overcurrent protection. So that's where you get that. That's where you get that. So
okay. Got it.
What else? We got a little bit more time. What else? Or what do you got?
Well, I know you asked me to get that lineman book, right? But I can't take it into the test. I've seen the only thing I could take is I got this one, my alarms.
Okay.
And I have my code book, and I think that's it, right? And the 10 something, the New Mexico one.
Are they allowing you in? I don't even know.
Yeah, they, let me see if I have it. It's Article 14.10.
Okay.
And I guess it's like a New Mexico code.
Okay. Did you go online and get the New Mexico code?
Yeah, it's like a little printout that it's a little link that
Yeah.
you can pull up through the PSI, I guess their bulletin.
Right. Yeah.
It's worked.
Yeah. I'll tell you what, it's not much. What, like 4 or 5 pages, maybe less than 10 pages?
Yeah.
And then but they do question you. They could question you on that.
Right.
So I haven't given you anything. Those questions that I shared with you, those were all from the linemen's, and once you read those, you'll see that they're really lineman questions, and they came out of that lineman's book. Also, they referenced the not the Ohm's law, the Uglies book for some reason, and all it is pretty much Ohm's law is what they're asking you on that one. And then What other one did I see? There's another, like a low voltage book. It's not the one you have there, but a low voltage book, but they reference it a few times, but it's not even worth, I don't think it's worth getting if we just study the questions that you have. So
Okay, I got another question on the last time I took the test, it I think it was for part 1 and 2. It asked me a lot of questions about solar panels, solar systems, photovoltaic. But for some reason, I'm having a hard time finding them, bro. Like whenever I'm on the test, I'm having a hard time finding those answers, even if I have the open book. You know what I mean?
on the photovoltaic stuff. Okay. All right.
I mean, even like before I did this New Mexico portion of the test, like I wasn't too familiar with the section or the article, but even even if it's in a book, you should be able to find it.
Right. Do you see something about the number of switches on a disconnecting means for photovoltaic? Do you have your code book there?
Yes.
Go to 690.13 C.
13.
Now be aware when they start asking you photovoltaic stuff, sometimes it's Ohm's law, but they throw solar system photovoltaic in there, so you're diving into the photovoltaic portion of it, and it's not, it doesn't, okay, you say solar or panels or inverters or something, but it has nothing to do with photovoltaic, but it just sounds good, and it's Ohm's law. So just be careful with that.
Right.
So you're looking at a 690.13C.
Yeah.
Maximum number of disconnects. I'm sorry, you're in the 17. I don't know where that's at in the 17.
Let me look it up real quick.
Maximum number of disconnects.
It's 690.13D.
D? Okay.
Yeah.
Okay. Under maximum number of disconnects, highlight 6 switches.
Okay. Got it.
So let's see, let me see.
For some reason, I did buy a program that helped me highlight the book, right? But nothing to be highlighted in this article. I don't know why.
I have very little stuff highlighted in this article. That, in fact, that was the only thing I'm sorry. 690.7.
Okay.
And in my book, it's maximum voltage. It's under part 2, circuit requirements.
Yes, it's the same article on this one.
Okay. And it says something about DC circuits on or in 1 and 2 family dwellings shall be, and then highlight 600 volts.
Okay. Got it.
And as I flip through, that's about all I have. Disconnects, we got the maximum number of those. That's it, man. That's all I have in the photovoltaic stuff.
Okay. Can we go over? We got circuit operational systems and class 1, 2, and 3 signaling circuits.
There you go.
I don't have anything on that either.
Okay.
And I think maybe the reason is because they asked for this in part 3, no?
Mm-hmm.
And that course I was only for the portion 1 and 2 of the test.
Okay.
So whenever I highlighted it, I guess it doesn't cover this.
I'll tell you what to do. Send me a list of what you need.
Mm-hmm.
And I'll get you what I have.
Okay.
Where you can get that highlighted.
Okay.
Let's get a little bit more prepared.
Good.
A little bit more prepared on that. Maybe we'll hop on here again and see. They're heavy back there. They're heavy back there in the fire alarms. What I can tell you is be careful. They like to confuse us by using class 1, division 1 versus class 1 low voltage. So you're in 500, the hazardous locations, which you're pretty well aware of on the hazardous locations. And then they start talking. Then they start talking alarms, which is class 2, I believe. And you're like, that has nothing to do with classified areas. So be careful. Be careful with that. So
that would be under fire alarm systems, or what would that be under? Or low voltage?
That's all fire alarm systems. What, 760? 760. There's some stuff in 760 that I do have highlighted, because that's the right back there in that area is where this code book is growing because of all the low voltage stuff. You know, they're coming up with codes protecting us, EV stations, the EV chargers, all that stuff too is starting to grow. So give me a list and we can go from there.
For sure.
So
yeah, that should be it.
Cool. Work on those questions.
Okay. How do you recommend I break them down, like in tens?
That's what I do. I tell you what, I am freaking old school. I get a stack of flashcards of index cards, and I write everything down. And this is what I did for my Texas Masters. I wrote everything down, you know, all the questions, everything that I needed to study. And then I took 5 and I memorized, or, you know, I got familiar with the 5, and then I added another 5 or 10. It's going to be up to you, but yeah, just bite away at it. And all of a sudden your big old stack over here is going to be over here because you've learned everything into this stack. I mean, I had, personally, I had over 200 questions memorized doing that way of doing it.
Okay.
Just work a little bit, then add some more and go from there. So that's how I study. That's what I suggest people do, but people do have different study habits, but that works for me.
Right. Okay. I think that's, so far it's been helping me. I've been doing the flashcards too. I was gonna ask, so you're an electrical instructor, or what do you do, man? I don't remember Google. I was looking for like a electrical school.
Okay, so I'm a superintendent for an electrical contractor. Then I'm an instructor at the IEC here in Las Cruces. So I'm an instructor there too.
Okay.
So I do the 4th year class, which on the 2nd semester of the 4th year is code, and getting the 4th year apprentice ready to test.
Cool. Okay.
So that's what I do.
All right. Sounds good, man. Thank you.
Cool, man. We'll be in touch. Send me that stuff over. We'll get something worked out and go from there.
Okay.
Hope this helped you out.
When are we gonna do another conference call? I know I told you I test next Friday and Saturday. So my test for the specialties is Saturday.
Yeah.
I don't know when you would have time again.
Get on my calendar. schedule us the time.
Okay.
If you can schedule it, I'm available.
Okay. That'll work then.
Cool. Cool. I will be sending you a little invoice here in a little bit, and then we'll go from there.
Yes, sir.
All right,
Thank you.
man. Have a good night. Steady away, and I'll be looking for another schedule from you, and we'll get on it. Go again.
Okay. Sounds
All right,
good, man.
Thank you.
Thank you. Have a good day.
All right, you too. Be safe.
All right. Later.
Thank you.